Welcome to Spring LIB.
Once again, welcome to a new problem. This time we're still dealing with diffraction, and this is diffraction grating. And as you can recall, we always have openings in these diffraction gratings. So you can imagine there's a bunch of openings, and it so happens that the actual gap is given us 3 centimeters. Obviously, we can change that to meters if we wanted. And there's going to be some light going through at a specific angle. So if we had an angle here, theta, and that theta would be given us 33 degrees. This is the information that's given. The light itself travels with a wavelength. Lambda is 600 nanometers. And then our goal in this particular problem is that we get to see a bunch of lines in the grating, and the diffraction, the diffraction produces second order. So the diffraction produces second order, and it has a wavelength of 600 nanometers. Our goal is to find these lines. So how many lines are we dealing with in this particular problem? That's our goal. And so we're going to go ahead and given that the width W is 3 centimeters and the order M is 2, and we also know that theta is 33 degrees and lambda is 690 newtons. So we want to find the number of lines, which is n. That's what we want to find out. We do know that d sine theta is given by m lambda, and d is given by w all over n. Remember, w is the width, as you can recall. So looking at these two pieces of information, we can bring the d down and say if d sine theta equals to m lambda, and d happens to be w over n, so w over n sine theta equals to m lambda. And so in this instance, we can still simplify this using algebra, multiply both sides by n. So we have w sine theta is m lambda n, and then we divide both sides by m lambda. And that gives us an appropriate formula for n, which is the number of lines. So we have w sine theta over m lambda. W is 3 centimeters. We can change that to meters, 1 meter over 100 centimeters. And then this is sine of 33 degrees. M is order 2, and lambda is 600 nanometers. Change that to meters. 1 nanometer, or 1 meter, is 10 to the 9 nanometers. And so we go ahead and simplify that problem. We end up having n being equivalent to 1.3616 times 10 to the 4, or we could say n is 13,616. So that's the value of n we're dealing with in this particular problem. and we can always simplify using the relevant equations. We can round it off if we wanted to, but this is the appropriate answer. So once again, we had a problem. In this instance, we're given the width of the diffraction grating as 3 centimeters. We wanted to find the number of lines going out with the light at 600 nanometers and the angle at 33 degrees. We know d sine theta is m lambda, and d is also w over n. N is the number of lines we're looking for. So we simplify the formula and plug all the values into the formula: the width, the angle, the order, and lambda. Hope you enjoyed the problem. Feel free to send any questions or comments, and have a wonderful day.